Hi friends, it's me Jekka and I'm out here at the James Wiley Shepherd Observatory, which is maintained by the University of Montevallo. So I'm going to do a quick talk about optics and how telescopes work. So in order to talk about how telescopes work, let's first think about what do they do, right? Astronomers use telescopes to be able to view objects that are very far away. They are in the night sky and all the way in space. So the first person who looked through a telescope into the night sky was Galileo. And he had a refractor telescope. He used this to discover that our moon had mountains, and he found 4 of Jupiter's moons. All right, so a refractor telescope only uses glass to collect the light and bend it. So we have our refractor telescope here. This is our first lens, is known as the objective lens. And this is going to direct light to a focal point. So the other lens is over here, and this is known as the eyepiece. Incoming light comes in through this direction. The lens will bend it, and it will come out to the eyepiece, okay? So incoming light comes in at both sides. It's coming in through all of it, but this lens is bent, and so the glass is bent, and it'll make it focus, and this is our focal point. And then the eyepiece magnifies what's at the focal point so that we can see it. So we're able to take light and an object that's very far away, using this glass to bend it. We're going to make it very small now in this focal point, and this eyepiece is going to help us magnify it again so that we can see it. So the refractor telescope is what Galileo used. And like I said, it can help you see planets in detail. However, there are some problems with using this type of telescope. One of them is chromatic aberration, which really just means that it can distort colors. Because it is made out of glass and it's collecting these lights, sometimes that can get fuzzy. Also, halos can be a problem, and that's when water kind of distorts an image. So if you guys think about stars in the night sky, you might notice towards the horizon that these stars look like they're twinkling, and that they're not actually twinkling. That phenomena is actually humidity in our night sky that makes it seem like the star is twinkling, but really it's because we're having to look through all of this water that's in the air. So kind of like how that works, it was causing distortion with the refractor telescope. So the second type of telescope is a reflector telescope. Now, a reflector telescope uses mirrors to work. So it's still going to bend light, the incoming light, and it's still going to create a focal point, but how it goes about it is a tad bit different. So here's our telescope now. So there's a curved mirror and a second mirror over here. So this is a mirror, and this is also our mirror. So the light comes in, bounces off of this mirror. It hits our second mirror, which is going to push it up this way. Light, again, coming in from all directions, bounces off the first mirror, hits our second mirror, and comes up. So now this, where the light crosses each other, is your focal point. And of course, we're going to have our eyepiece up here so that we can magnify what's at the focal point and see it with our eyes. So this is a reflecting telescope or reflector telescope, and these are really good to see galaxies and deep space objects and like binary stars, things like that. So if you want to look into really deep space, you're probably going to have a reflector telescope. That's what we have here housed at the James Wiley Shepherd Observatory in the dome, right? We'll check that out in a second. So there is a third type of telescope, and it is kind of a hybrid of a reflecting and a refractor telescope, and that is called a compound telescope. So here's our telescope body, and on this side is going to be our lens, kind of like the first one, right? And on this side we're going to have our curved mirror. So light comes in, bounces off the mirror, bounces off the lens, and comes out this way, okay? Light coming in, bouncing off the mirror, hits the lens. Here's our focal point. And of course our eyepiece is over here. So now we've discussed the three types of telescopes and how light and mirrors and glass can help us see objects that are very far away. I hope that one day you guys get to come out here to the James Wiley Shepherd Observatory and see through the telescope really cool deep space objects. This one behind me is what we call our binoculars. This one's better at seeing closer up objects, so we can see things within our solar system like the moon in great detail. It's very cool. So I hope you guys get to come out here. We also do have a solar scope, which works a little bit differently. It can actually view the surface of the sun, and that's because it has specific filters that help protect our eyes. Otherwise, you should not be looking directly at the sun because it will damage your eyes. Thanks for joining me today, guys. I hope you guys had a lot of fun. Let's go check out the rest of this place. So this is the gate, our first entrance to the observatory. And this door was designed by art students. You can see that it lines up so that the dome is perfectly in the center as you drive up. Our facility was built with sustainability in mind. So this entire facility is solar powered. This behind me is one of our solar panels. This actually helps pump water. So there's a spring downhill from here, and this pump will activate whenever our water reserve, that green building up there by the garden, needs water. It'll activate down here, and it uses solar power. How cool is that? This is the Virginia and Samuel Condrey Garden. So now we are approaching the control room, which is very cool. All the magic happens here. This is the door to the control room. General Ivan Smith's control room. And on this, you will notice there's a constellation. Can anyone guess what constellation this is? Leave your guesses in the comments below and I'll let you guys know who is right. So this is our control room. In here we keep a lot of the supplies we need to keep this place going. Also, what's really cool is our solar scope. So a solar scope helps us look at the surface of the sun, and it has special filters so that we do not damage our eyesight. So here's the solar scope. It requires a little bit of assembly, but this is what we would use during a field trip if you get to come out and see us. Here is actually an example of a refractor telescope. So that's the one we talked about that only uses lenses in order to bend the light and help you guys see things like planets in great detail. Let's continue the tour. Oh, and we got red lights. We don't want any kind of white light to interrupt our night vision, and red light does not. So we have the control room with red light so that if we need to run in here real quick, we will not interrupt our night vision. We're here at the dome of the observatory, and there's some really cool details on this door that I want to point out to you guys. So at the top here, you can see Maxwell's equations. And astronomers have to rely on these equations. They don't necessarily need to calculate all of these equations by hand all the time, but having an understanding of these helps them understand what they're seeing and what they're looking at when they look into space. So the telescope that we use inside the observatory is a 20-inch reflector telescope, which means it uses mirrors, and it can see really cool deep space objects, as well as our planets and closer things in fairly good detail. If you are able to join us for a star party, we host them and they're open to the public. Then when you come out here, you'll notice that there's no lights. I'm out here during the daytime, but we actually need our night vision intact in order to be able to see the most stars and the coolest objects. So when you come out here, there's no lights. If you do bring like a headlamp, we suggest one with red light because red light will not interrupt our night vision. So hopefully I get to see you guys out here soon.